Hello everyone! Today we will talk about momentum and we will show you an experiment about momentum. First of all, I would like to introduce our group members, Muhammad FAIZ ANUAR, AHMAD SYAZWAN AZIZ AMINUDDIN, and FAZLIN SUHANA Muhammad ASRI. This video are for our semester 1 final project, which is ASP0504 Physics 1, and we are from Kuliah 12, and our lecturer is Dr. Zulkarnain Endoi. And I would like to proceed to my friends to talk to you about momentum.
Impulse momentum. Impulse is defined as product of the average force and time. Momentum is the product between mass of object and the velocity of the object. Newton's second law of motion states that rate of change of momentum of an object is proportional to the force acting on the object. Delta P over delta T equal to F. Therefore, delta P equal to F delta T equal to I. The impulse of an object is equal to the change in momentum of the object. Conservation of linear momentum. The principle of conservation of linear momentum is the total linear momentum in an isolated system is always conserved. Then, isolated system means no external force on the system. The principle of conservation of linear momentum can be applied in two colliding objects, which is snooker ball, explosion of object into pieces, which is shotgun. Collisions. The average force is large and causes large effect because the impulsive time is very short. F equal to mv minus mu over delta t. So, the effect of impulsive force can be increased by increase the change of momentum and decrease the time at which force acts. Also can be reduced of the effect of the impulsive force by increasing the time of contact. Collisions are divided into three, which is elastic collision, M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. Then, in elastic collision, M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. And the last one is perfectly inelastic collision. M1 U1 plus M2 U2 equal to M1 plus M2 times V. There are two types of collision. One, collision is that one dimension, head-on collision. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. The second one is collision in two dimension, oblique collision. X component M1 U1x plus M2 U2x equal to M1 V1x plus M2 V2x. Y component M1 U1y plus M2 U2y equal to M1 V1y plus M2 V2y.
Okay, now we will show you an experiment about momentum, which is two-dimension collision. Okay, we will start the experiment again. You see, the two-dimension collision will involve two balls, and after the collision, there will be an angle for the balls to move. We'll show you the experiment again. So, for your information, the mass of the first ball and the second ball is the same, which is
0.0459 kilogram.
and the time taken for the ball into collision is
0.7 second.
so, and the distance for the ball to for the collision is
0.015 meter.
by using the value that we can get the velocity, the initial velocity of the ball A, which is
Before the collision, the ball A is 6.86 on Vx and on Vy negative 0.165, and after the collision, the velocity of the ball A is 0.113 on Vx and negative 0.135 on Vy.
as you can see here, the velocity of Vx of ball A is positive value because it moved forward, and the velocity of Vy is negative because it moved downward. So the velocity of Vy is negative. The angle after the collision of ball A is 56.7 degree. It is counted by the tracker. And for the ball B, the initial velocity are 0, and after the collision, it moved at the angle of 10.7 degree, and the velocity of X component is 0.74, and the velocity of Y component is 8.735.
From this information, we can get the acceleration of ball A before the collision is 1.057 meter per second squared, and after the collision, the acceleration of the ball A is 0.798, and for the ball B, it starts from rest and the acceleration is 1.327 meter per second squared. Okay, we can get the graph of ball A and ball B. Okay, that's all from us, and thank you.